quadratic function you can think of, because we have not practiced the difference quotient. So can anyone make up a function? Quadratic.
2x squared.
Okay, negative 2x squared, let's say. Plus 5x. Minus 10. Awesome. Very good. So remember what we are trying to do with a difference quotient. Maybe I should come back here for just 1 second. Look at the difference quotient. The difference quotient is basically giving us the rate of change of a function between 2 points. That's what it's giving us. Okay? So which is nothing else but the slope of this line. The slope of this line will give us the rate of change of this function between a and b. But I have to find the slope. Okay? So in order to find the slope, this is what I'm trying to determine. So coming back, so the question here is find and simplify the difference quotient for this function, f of x. So find and simplify the difference quotient. In this class, you do not have to memorize the difference quotient. It's easy, but you don't have to memorize it. So difference quotient is f of x plus h. I need to have this open so I can see if I'm centered. So f of x plus h minus f of x over h. In order to find and simplify the difference quotient, I'm looking at this expression and I'm asking myself how many pieces I have here. First of all, 3 pieces. I have this piece, I have this piece, and I have this piece. Correct? Okay, which of these 3 I need to determine? 2 of them I can do anything to. But there is one that I don't have and I really have to work on.
H.
Oh, I can't do anything to it. It's simplified, it's just h. I can do anything.
Figure out what the f of x is.
F of x is given. There is nothing I can do to it. Exactly. This is clear. This is clear. This I cannot do anything to. This I cannot do anything to. This piece I don't have. This is not calculated yet. That was first question. Second question is, I'm looking at this function and I'm asking myself, what does this function say to me? It says negative 2 times blah squared plus 5 times blah minus 10. So now if you ask me to find f of x plus h, I know what to do because I know how to read the function. Negative 2 times whatever squared plus 5 times whatever minus 10. So please dictate what I should write. Ready? Negative 2. Parenthesis. Very good. Very good. Very good. Plus. Yes. And parentheses, it must be. Very good. Minus 10. Awesome. I am only mimicking what the function is telling me to do. Minus 2 times whatever squared plus 5 times that whatever and minus 10. Perfect. So now, I remind you we have a contract and I'm asking you to continue and I will write. Yes. 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 Yes.
Plus xh.
Thank you. Plus awesome. Plus See how easy this is now once we establish that, and now it's boom, boom, and I don't have to write it on the side and multiply it and FOIL it. There is no need for that. Awesome.
Also,
And
this is the 2AB.
exactly. Yes. Yes. Good. So now I can say that I have all pieces. So I can continue here. Can anyone dictate the first piece that I have to put in?
Minus 2x squared.
Now I will distribute. You're right. Now I will distribute. Negative 2x squared. I should have written it one more time. Sorry about that.
Minus
Yes?
4x each. Minus 2h squared.
So I only finished with this piece. Now I'm here. I must distribute negative 1 to all three terms. Please dictate.
Negative 2
I must distribute negative 1 to all three terms.
plus 2x
Very good. Now let's stop for a moment because I want to tell you two things. Finished?
Yes.
Very good. Thank you. Done? So after this we can. Okay, ready? Two things for any function. Anytime I need to determine the difference quotient for any function, two things will happen. Number one, at the top, all terms without h must cancel out. They must disappear. Some of the terms with h may disappear. I don't care. But those without h must go away. Second thing that has to happen, this h in the denominator must go away. Somehow. We'll see how in a minute. So two things. At the top, terms without h must all cancel out somehow. Second thing that has to happen, h in the denominator must go away. Okay, good. So let's look at the top. Does that happen? Terms without h go away or not?
Yeah.
So I see a negative 2x squared with a positive 2x squared. What else?
5x and 10.
I'm sorry. Be very careful here. I copied something else by mistake. I wrote 5x twice. So this is 5x and this is 5h. Please correct that. Sorry about that. And you're right, the 10 and the negative 10. Very good. How many terms are left at the top? How many terms are left at the top? One more time. How many terms are left at the top? Three terms. So here's 1, 2, 3. What do they have in common? How many terms will you give me in parentheses? Exactly 3. If you start with 3, you have to give 3. So please, I'm ready for your terms.
4x
For negative 4x
minus 2h
minus 2h,
plus 5.
that's it. So all terms from the top with no h went away. Then I factor out an h, and now the denominator will go away. So say it again.
No square.
H times negative 4x is this. H times negative 2h is that. And h times 5 is that. Is that okay? Good. So as you see, the final simplified form still has h in it, but not this one. So that's okay. That's allowed. But not this one. That is gone, as expected. Good. Let's look at what questions did we have on the classwork from last time. Any problems? Yes, Kelsey? Yes. You had a question on the classwork? On the classwork? You had another question? Okay, okay, I'll come back. Yes, Kelsey? I'm not sure whether she's ready yet.
3, I'm not, x or 1 minus x over 4 times 2, greater than 10.
Right. Good. So we did it a few times before we started today. I have to clean it up. I have to add 2 and divide by 3. Are we in agreement with this already? So I'm adding 2 and dividing by 3. Yes? Okay, now I have to ask myself this question. I'm asked to find numbers whose distance from 0 is 4 or more. These numbers whose distance from 0 is 4 or more. How do I get that? And remember, there are only 2 possibilities. If we were talking about 15 different possibilities, I would have said, oh, that's hard on my students. But there are only 2, right? It's either this or this. Which one is it? So, one more time. I'm trying to find numbers whose distance from 0 is 4 or more. Is it in between or is it outside?
Outside.
It's outside, meaning greater than what?
4.
Or less than?
Negative 4.
Less than -4. So that's what I have to change this into. 1 minus x over 4 greater than or equal to 4, and 1 minus x over 4 less than or equal to -4. Then solve and then put the union together. Is this good enough or we need to finish it? I'm sorry? Yes. So I subtract 1 from both sides, negative x over 4 greater than or equal to 3, and I multiply both sides by -4. So x is less than or equal to -12. Then for the other one, I subtract 1 from both sides. I get negative x over 4 less than or equal to -5. Again, I multiply both sides by -4, and I get x greater than or equal to 20. The solution has to have the union in between. I have to put this first, starting from -infinity to -12, and union 20 to infinity. Solutions will be posted for all these, of course. I was just waiting for students who missed class to take it, and then I'll post the solutions. Is this okay? Other questions for me? Anyone else? Yes, please. This is the same thing we just did. I'm sorry? Yeah, this is exactly what we just did. Right? We should have given this function. But this is exactly, is that clear?
Yes.
Okay, good. Other questions for me? I'd like to show one more piecewise defined function, because we only looked at one last time. Okay, ready? I'm going to make one up. Of course, we're asked to graph. Damon? Piecewise, defined in pieces. Piecewise defined function. And we're asked to graph it. Piecewise defined function, and let's graph it. I'm going to make one up. Let's say -2x for x greater than or equal to 2. And x plus 1 for x less than 2. How many pieces does this function have? 2. 2 pieces, 2 functions, right? 2 pieces, 2 functions in one. Very good. So can anyone translate this in interval notation and then this in interval notation?
The first one would be open parenthesis. Oh wait, we have a okay, I can see that. Bracket 2, comma, infinity.
Awesome.
That's bracket. Parentheses.
We agree? Any questions on the interval notation? Greater than or equal to 2, which means 2 to infinity, less than 2, negative infinity to 2. Okay, so every time you're asking me or I get a question on graphing a function, what is my first thought? And I strongly recommend you create that little notebook in which you write down the way I solve a quadratic equation by factoring is such and such. The way I solve a radical equation is such and such. Determining the domain of such a function, blah, blah, blah. Graphing a piecewise defined function means blah, blah, blah. Whenever I'm asked to graph a function, the first thing that I have to determine is
One more time. I'm sorry.
I've been talking too much. Right.
That's why we get so just
We're like,
try to
oh,
keep
we
it
supposed to answer.
So the question was asking you, when I'm asked to graph a function, what is my first thought?
Example of X.
Yes, but what is the name? You're right. What is the name of that I have to determine first? Always. Every time you ask me to graph a function, that's my first thought. Exactly. Domain. I cannot start without finding the domain. Very good. So now, can anyone tell us the domain of this function? I would put that in my notebook. Every time I'm asked to graph a function, I have to find the domain first. Good. What is the domain for this function? Negative infinity cannot be a domain. Yes, why is it negative infinity comma infinity? Because the function is defined at 2, is defined for numbers greater than 2, and is defined for numbers less than 2. These two intervals give us the entire real line. We agree? Yes, everyone? Is that a yes?
Yes.
Okay. Very good, so that I can get my chart going. So here it is. Negative infinity, infinity. Without this, I cannot do anything. This is my starting point, always, the domain. Okay, perfect. So what is the next step here? I cannot find the range till I graph it. That is the last thing I need. So what numbers do I put in the chart? Y2 has to be in the chart. 0 has to be in the chart, but Y2 is the most important point here. X value. What happens at 2?
Changes over from
Exactly. That's the answer. It changes over from one function to the other. So such an important point, something happens there. It changes from one function to the other. Perfect. So now carefully how I continue. I see negative infinity to 2 facing left, a parenthesis. I'm going to copy the parenthesis immediately under 2, facing left. Then there is a right bracket facing right. I'm going to write it or copy it right here under 2, and it's touching the parenthesis. Now this is an overkill, but I need it. I need to see it right here in front of me, and I'll explain why. Can you please tell me which function, which piece, which is also a function, will you use for negative infinity to 2?
X plus 1.
Indeed, very good. This is tricky. I intentionally reversed them. This was intentional. To make sure that you understand that this is negative infinity to 2, and I have to use this function, and I'm going to write it here. I know this is redundant now. Which function will I use for 2 to infinity? Right, it makes sense. What type of functions are these? Because if they are quadratic, I need this several points. If it's absolute value, something else. If it's,
Linear.
yes, it happens that we picked two easy linear functions. Perfect. Okay, so now let's pick 0. It has to be there. And I know that this function is 0 when x is negative. X plus 1 is 0 when x is negative 1. I have to move 1 to the other side. So I'm going to use negative 1 as well. So plug in negative 1, what do we get? Of course. Plug in 0, what do we get? Plug in 2, and you should say no. Why should you say no? Because I cannot plug in 2 in this expression or function. I can plug into here. Bear with me if you remember from last time. Bear with me and we'll see what happens. Please plug in 2. Right here inside of these parentheses, I put a 3. Now on the other side, inside the bracket, what will I write? Very good. And just one more value and tell me what to write. Yes, Damon? Can you see from there?
Yeah, I can see.
Very good. From left to right, give me step by step all ordered pairs that I need to plot. Negative 1, 0. Next ordered pair, please. Next ordered pair, please. What type of point is this? I wasn't allowed to plug in 2.
Open.
Exactly. I took the liberty to plug in 2 and I wasn't allowed to, which means that point does not exist. But everything coming up to that point exists. I cannot stop here or here or here or here or anywhere. I have to go to the point except that particular one. But everything else has to touch that. Just that is open. Okay, perfect. I'm done with x plus 1. We can forget about it. We cannot extend this green graph to your right. Okay, now next point. Say it again. I am not there yet. Is this the full point or an open point?
Go point.
Full point because of the bracket. Here it is. And one more point, please. And this is the graph of the piecewise defined function. You understand that if I put this as a full point, at x equals 2, I will have 2 points, and this will not be a function anymore by the vertical line test. Now, after we have the graph, now we can identify the range. Can anyone identify the range? From the lowest y value till the largest y value. From the lowest y value, from the lowest y value to the largest y value. Closed or open?
The infinity parentheses,
Because the point does not exist. Yes. So the range of this function is negative infinity to 3. Any questions for me? Any questions? Okay, so to that, yes, Damon, go ahead.
Yeah, so when you hit that, I'll catch it. I just want to, I got all my points and stuff.
So this is okay, this is okay, this is okay, but this one has to be open.
Right.
So make a circle, okay, and then connect these 3 points. Awesome, with an arrow. Good. And now you have 2 comma negative 4, which is this point, which is full.
Right.
This is open, this is full. And then you have 3 comma negative 6. Exactly. And just connect them from here down. You're done. Exactly. That's the function. Is that okay?
Yeah.
Okay, sorry about that. So we're coming back to something that I'm sure you have experience with. Regardless, I like to review everything. So we know this equation, y equals mx plus b. What does it represent? Slope-intercept form. Right. So this is an equation of a line. And the name of the equation is slope intercept, but I like to be specific. Slope y-intercept form. There's nothing wrong with saying slope intercept form, but it's really the y-intercept. There exists an x-intercept as well, so that's why I like to write slope y-intercept form. What does m represent? Yes, it is. Which is also rise over 1. So now if we have 2 points, let's say I have point A, which is x1 comma y1, and I have point B, which is x2 y2. How will I write the slope given 2 points? That's the denominator because the rise is in difference in y's. X, yes, indeed. y2 minus y1 over x2 minus x1. Any questions? Okay. What about B? What does B stand for?
Y-intercept.
Right, but it should be always in your mind as an ordered pair, right? 0 comma B is the y-intercept. Not just B, but 0 comma B. Good. Types of lines. 4 different types of lines. This is one. This is the other. This is the third. And this is the fourth. Well, types of lines when it comes to slope, basically. We have 4 different types. Okay, this one. Is this one a positive trend or a negative trend? Positive, which means the slope is, that's it. What about the next one? What type of trend is this? Negative, so what about its slope? What about this? What type of line is this? Very good. And what is the slope of a horizontal line? Perfect. And what type of line is this? Very good. What about the slope of a vertical line? Thank you very much. Undefined. It does not exist, in other words. There is no slope. Very good. What if I'm given a point? Let's say point A, x1, comma, y1, and the slope. Given a point and the slope. Find the equation of the line. If this is a point and not the y-intercept, I should put that in parentheses, not 0 comma b, that's what I meant, then I should not be using y equals mx plus b. Can I? To find the equation of the line, I can. But this is like doing this. instead of doing this. I don't recommend it. If you were taught in high school or somewhere else to do it, do it. I'm fine. But I don't recommend it. So there is another equation that we will be using, which is y minus y1 equals the slope times x minus x1. What is the name of this form, of this equation of a line? Point slope. Point slope form. Indeed, this is the point slope form. And I want to review one more thing, and then we can look at problems. Parallel lines, perpendicular lines. Okay, so let's look at two lines. This and this. And now I will ask you, here are my two lines. What is the relationship between their slopes?
Same.
Of course, makes sense. If this line has slope m1 and this line has line has slope as m2, the relationship is m1 equals m2. Otherwise, they will not have the same slope. They will not be parallel. Good. So let's look at two lines that are perpendicular. Two lines that are perpendicular form four 90-degree angles. 90 degrees, 90 degrees, 90 degrees, 90 degrees. I'm going to call the slope of this one m1 and the slope of this one m2. So, what is the relationship between the slopes of these two lines now when they are perpendicular?
Inverse.
Negative.
Negative inverse.
Negative multiplicative inverse. So the relationship here is m1 equals the opposite of 1 over m2. I personally don't remember it like this. I cross multiply. So I like to remember it as m1 times m2 equals negative 1. It's easier for me. It doesn't matter. It's the same thing. If you put this over 1 and you cross multiply, you get this one. Good. So let's look at a few examples now. Any questions for me?